Hello everyone and welcome to another homework solutions video. So today we're going to start with question 5 from this week's homework, which is problem number 6 on page 575 of the textbook. So in this question we're given a picture of a standing wave. So we have a square wave here and it has some amplitude A, and this is our time zero snapshot graph. And so the question asks us to draw the snapshot graph at time 1.25 seconds. Now one thing to note about this is that we have a fixed end at x equals 3, which means our wave is not going to be able to travel beyond x equals 3. So to be able to draw this, we're going to have to draw both the real and imaginary waves and then superimpose them together. So I'm going to use blue for our real wave, and we're going to be drawing past the point x equals 3 for the time being. We do remember that nothing is actually going to show up on the wave after that point because we have a fixed end there, but for thinking through what's happening, we're going to translate the whole wave over by 1.25 meters because it's moving at 1 meter per second. And so if this end moves over by 1.25 meters, it's going to end up at the new position of 2.25, which is somewhere about right here. And then this end, which is at 2, is now going to be at 3.25. And again, the stuff that's happening beyond 3, we're not actually going to see or anything like that, but it's a good way to think about it. So if we want to think about what's happening with our imaginary wave, well, we're going to use red for this. And you can think about the imaginary wave as when this one hits the fixed boundary, the imaginary wave is going to be on the other side of the fixed boundary lined up exactly. So this one's going to hit the fixed point, the end's going to hit our boundary after 1 second. So after 1 second, our imaginary wave would be right here. So we have to translate it over by 0.25 meters to the left. Now I am skipping the step of drawing the time equals 1 second graph, which I usually do in the interest of making this video a little quicker. If it's helpful for you to draw the 1 second graph, then by all means draw what happens after 1 second and then move on to 1.25 seconds. But I'm just trying to make this a little bit speedier, so we're kind of cutting out that step. And so our imaginary wave is going to be, if the end was at 3 after 1 second, then if we go over for another 0.25 seconds, well, it's going to be over at 2.75. So it's again going to be mirror image and upside down. So it's going to look like this. It'll have an amplitude of negative A. And so this is what our graph would look like. Now we have to add these together because this is not what we're actually going to see. We don't actually see the imaginary wave, even though it's interfering with our real wave. So we have to use the principle of superposition to add these together. We can see between 2.25 and 2.75 meters, we're going to have just the blue wave as it normally is. So 2.25 is about here. And then over to 2.75 would be about here. So we're going to have a wave that looks something like this. Now if you look at the red wave, so this is an amplitude of minus A, this is an amplitude of A. Where the red and blue waves overlap, they're going to completely cancel each other out. So once we hit 2.75 meters, this one's going to drop back down like this. And that's what our graph would look like. So this is what our time 1.25 second graph would end up looking like.